Hello class, this is Mr. McAllen, and I promised you I would go over a video detailing how to solve log equations, just to remind you what we started talking about in class today. And so what I have on the board is our objectives. Basically, we want to first know the properties for solving log equations, and we're going to go over that, and then we're going to solve three types of log equations. One type is just a log equation, where on either side of the equal sign we have a logarithm. The next type is where we have a log on one side and no log on the other. And the last type is where we have two logs being added or subtracted on one side and a logarithm on the other. So let me just share with you the properties again of logarithms. And this is our little table that we went over that was in our packet. And what this rule says here is that if you have two logarithms and they're being added with the same base, you can compress them into a product of the two, let's call that the two interiors of the logarithms as a product. So for example, if you have the log base 2 of x plus the log base 2 of 10, that can be rewritten or condensed as the log base 2 of 10x. And if that property of addition holds for logarithms, where it turns addition into a product, you can say that subtraction would turn it into a quotient. So the log base 2 of x minus log base 2 of 10 would be log base 2 of x over 10. And that's signified by the subtraction turning into a division in one logarithm. And the last part is if you have a coefficient, let's say you had, I don't know, 2 log base 3 of y, that could be rewritten as log base 3 of y squared. The 2 just changes location and becomes the exponent. So with that in mind, we're going to do a few example problems. So I'm going to do the ones from the handout so that you can see how to do those, and then you can apply that to what we do in the book for homework tonight. Okay, if we look on page 11 of our handout, page 11, number 9, they start us out with log base 6 of x plus log base 6 of 9 equals log base 6 of 54. You can condense these two logarithms on the left to be log base 6 of 9x, and that would equal log base 6 of 54. And as a result, because you have the same logarithm on each side, you could just consider 9x equaling 54, and x would equal 6. So this is what you do when you have a scenario of a log plus a log equaling a log. That was one type of problem we said we would take care of. Another type of problem is where you have, on page 11, you have a log of a number equaling another number. So you just have one log, so what you have to do in this is use properties of logarithms and convert to exponential form. In this case, you would take x raised to the second power is equal to 25. That's just rewriting the logarithm as an exponential. And x would equal 5 or negative 5, because both numbers, when you square them, would give you 25. And then we have one other type of problem that we did on page 11, and that would be where you had logs on both sides, just a log equaling another log. Just make sure the bases are the same. So I'll highlight number 3, and that said log base 3 of 9x minus 1 equals log base 3 of 4x minus 16. And because the logarithms are the same base and you only have one on each side, you can just set 9x minus 1 equal to 4x minus 16. and that would give you 5x is equal to negative 15, x is equal to negative 3. Let's do a couple more of these complicated logs that were at the bottom. Let's say number 12. This one appears to be log base 9 of 3x plus 14 minus log base 9 of 5 equals log base 9 of 2x. So in this case, you turn the logarithm on the left into one log as a quotient because of the subtraction. And then you would just, because now you have a single log on each side, you just set the inside, the interior of the logarithm, equal to the interior of the other logarithm. And when you cross multiply, you get, x to equal 2. And you should always go back and check that by plugging that in. So you would have over here log, I'm going to plug 2 in, I'm going to have log of 20 minus the log base 9 of 5. Does that equal log base 9? I'm going to plug 2 into there of 4, and as you can see, log base 9 of 20 over 5 does equal log base 9 of 4, so the solution checks out. Okay, class, well, that's all the time I have for this brief introduction, but I will be making one more video that will detail how to solve some other log equations, and they'll be from the book. So I suggest that you watch that one as well. This video is only taken about 7 minutes. Hopefully you can tune in for that other video to see how we do some more complicated log problems from the textbook. I hope this helps, and we'll see you soon. Take care.